So after the hydrogen atom problem was solved, and we came to know about these three quantum numbers n, l, and ml, people thought that life was easy. So we know everything we need to know about an electron, and we can do whatever we want. Then came a famous experiment. Is Stern and Gerlach. They were two scientists who did an experiment known as the Stern-Gerlach experiment. So, what did they do over there? They took a chamber, put two large magnets on its side, so there is a magnetic field in the center, and then took Ag atoms. So the first question which we should ask, why Ag atoms, right? And then they took Ag atoms and passed it through the magnetic field. So to answer why did we take Ag atoms, the first question is, what is the atomic number of Ag?
Atomic number variable.
Atomic number of Ag? Jam aspirants. Okay. So Ag is a d block element. So if I remember the d block correctly, Cu, Ag, Au will be 47. So this has 3D, 4D, 5D. So what I want to know is its final configuration. So it has a 5D one. So first, because copper has a 3D one, right? So it should have a 5D one. R is human. So it is a 4s1, 5s1, and 6s1. So it has just one electron in its outermost shell, which is the farthest away from the nucleus. This one over here is what we should be concerned about, since we are bombarding Ag atoms. Classically, if we look at the thing classically, what do we expect? That there is some electron over here which is being bombarded. There is a magnetic field, so there should be some sort of a hue over here of those atoms. Continuum. A continuum of the Ag atoms somewhere over here. If we look at it quantum mechanically, then what is the number over there associated with magnetic moment? ml. ml is dependent on L. So if L is equal to 0, 0. So there is no effect of the magnetic field, there will be some sort of no splitting over here. It will just be something over here which shows no splitting. If by some means, if there is a promotion of this 6s to a p orbital, so then L equal to 1, ml can be. So the magnetic field splits it into 3 energy levels, and there should be 3 different spots over here. Now we do the experiment. What we see, there are 2 spots. So the classical explanation is not matching, the quantum explanation is also not matching. So we are definitely missing out something. Now people began to question that what are we exactly missing out over here? Is there some sort of hidden variable out there which we haven't taken care of? Is there something else which we want to see? Okay. Now, to solve this, someone called Gauss-Smith and Uhlenbeck. Gauss-Smith and Uhlenbeck, two very renowned scientists, proposed that there should be another variable which, let us for the time being denote by S, which is causing this phenomena to happen. Now, this variable over here is purely quantum mechanical and has nothing to do with any observable which we have seen so far. Each observable, N, L and ML, has some sort of a classical analog to it. We can correlate this with that. Spin, which we are going to call this new quantity, has no classical analog. We just define it to be something which follows the same algebra as that of angular momentum. We can say or extrapolate that it is some sort of an intrinsic angular momentum an electron has, but we cannot see it being classical. You cannot imagine an electron rotating like this so that it has a spin. Spin is something purely quantum mechanical and we cannot visualize it. We did this experiment, we saw a phenomena, to explain the phenomena, we bring in spin. That's how spin came into being. So many people confuse it with the thing that an electron actually moves around the nucleus, so that is the angular momentum. It is moving around its axis, that is the spin. No, that is not spin. It was called spin because of that reason, but that is not why the spin came into being. Because if that was the case, we would have got it from here. We are manually putting it in. So, what we say is that this spin over here, it follows the same algebra as that of angular momentum. Okay. So, angular momentum was characterized by two quantum numbers. One was L, and the Z projection of that angular momentum was NL. Since I say they follow the same algebra corresponding to L, the total angular momentum, there will be something called a spin. And corresponding to ML, there will be something called an MS. So, how many values can ML take? So, how many values should MS take? Fine. Any questions, doubts, anything? So Ag is larger in size, so the electron is far away from the thing. You cannot get bold atoms. How will you? Foils? No, we are bombarding atoms from over here. We are spraying atoms. What's the So, maybe it was possible. ঠিক আছে, so L এর corresponding একটা S পাচ্ছি, ML এর corresponding MS পাচ্ছি। আর আমি তখন থেকে একটা জিনিস বলে যাচ্ছি, এগুলো হাতে ওরা কিছু নেই, আমি দেখেছি এটা হচ্ছে, তাই আমি বলে যাচ্ছি। This is how it came into being. So, what was the energy splitting over here? 2. So, 2s plus 1 will be equal to 2 because there are 2 splittings. So, S is equal to, that is S is equal to half and MS is equal to plus half and minus half. Fine. So that's why we say for an electron, the spins are plus half and minus half. Okay. So this plus half over here, let me call it as up spin and this as down spin. Fine. Let us think of the angular momentum algebra a bit and correlate it with the spin algebra. So Lx, Ly commutator, remember it was something else. IH cross Lz, Lx Ly is IH cross Lz. Right? So I say Sx Sy will be IH cross Lz. So do you remember it used to do something like Sx goes to Sy and then it goes to Sz. This sort of relation, x, y, z. So the next relations will be sy, sz will give me IH cross sx, and finally sz, sx will give me IH cross sy. So we get three relations. So another very important thing is corresponding to R there is a radial wave function. Corresponding to phi and theta there was an angular wave function. So corresponding to S there should be S and Ms there should be a spin wave function. So if I denote this spin wave function as phi, which is a function of S and Ms, the S operator acting on phi will give me S into S plus 1 times phi. Because L and I square is because L square acting on the angular part used to give me the total angular momentum L into L plus 1. কথা আসছে না নাকি ভুলভাল বলছি এটা ভুল বলছি না ঠিক আছে
না সিক্সিবলে কি কারণে যেটা হচ্ছে সেটা হচ্ছে আমাদের যে এর ক্ষেত্রে আর এর সাথে করেসপন্ডেন্স ছিল এর আর এর ক্ষেত্রে থিটা এর ফ্র্যাকশনাল করেসপন্ডেন্স ছিল এই ক্ষেত্রে তো আর কোনো ভ্যারিয়েবল নেই
কোথায়
এস এর
এস এর ক্ষেত্রে এস আর এম এস আছে এস আর এম এস এর জন্য একটা
এটা কোয়ান্টাম মানে ভ্যারিয়েবল মানে স্ফেরিক্যাল কোঅর্ডিনেটস
পিওরলি কোয়ান্টাম
মানে এর ক্ষেত্রে কোনো ভ্যারিয়েবল নেই
ভ্যারিয়েবল
মানে আর থিটা ফাইয়ের মতন কোনো
আর থিটা ফাই মতো না
মানে এক্স ওয়াই থেকে আর থিটা ফাই
পজিশন ডিপেন্ডেন্ট করছে
Phi is something, is some wave function which gives us information about the speed.
পজিশন
For now, let us consider it to be something which gives us information about the speed. What does it? A function. A function. If you ask me about the coordinates, it's a good question you're asking me about the coordinates. It's in some imaginary coordinate we have no idea about. It's in some imaginary coordinate we have no idea about. We can get some idea about it if we project the spin to Ms and get some observable out of it.
But observable powers are
Plus half and minus half. It has variables. It is in some imaginary plane which we don't know. So normally we tend to characterize that imaginary plane by omega.
ভেরিয়েবল থাকে সেই ভেরিয়েবলটা আমি সেটা বলতে পারি
As similar to theta alpha. Therefore they follow the same algebra.
আমি জিনিসটা জাস্ট ইমাজিন করা যাচ্ছে যে এর অ্যানালজি
হ্যাঁ।
কি হতে পারে
Exactly. That's it. Questions? Follow. Give me more questions. Doubts, questions, spin amount of বুঝে যাচ্ছে তো
আচ্ছা ওই ম্যাগনেটিক ফিল্ডে সিলভার পার্টিকেলগুলো মানে কিভাবে মানে জাস্ট একটা কি বলবো আনপেড ইলেকট্রন ছিল মানে বাকিটা পুরো ঠিক একটা তাহলে ওটার জন্যই আমি ধরে নিচ্ছি যে যেটুকুনি আমাদের যে দুটো আসছে কিন্তু দুটোই আসছে সেখান থেকে এই ডিডাকশনটা কিভাবে সেটা বুঝতে পারছি ওই 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 জাস্ট ওই ক্যালকুলেশন যে আপসুইং আর ডাউনসুইং দুটো হবে
So first people said that there is some variable which we do not have any idea about, and that variable is causing this field. Then people said that this phenomena is occurring due to a magnetic field. So it has something to do with the momentum, angular momentum, but not specifically this angular momentum which we observe. So something, a variable which follow the same algebra as that angular momentum is present over here. So we describe spin completely with the help of angular momentum, get this, and then plug in this equation since we are getting those spins. This is how the thing was done. All this idea was already with us because we had solved the momentum or angular momentum. So we already knew about this. That is all spin is about. And they say that this mathematics which we are doing it for some variable which is purely quantum mechanical and has nothing to do with any observable quantity in nature. And therefore the variables are in imaginary space. Fine, so far so good.
And this has no relation with the spiritual relation. There are no part of it.
This is plugged in manually. Jodo by hand. But so another very good equation you all are already familiar with is fine. এটা টোটাল অ্যাঙ্গুলার মোমেন্টাম জানিস তো ডেল স্কয়ার অ্যাক্টিং অন হয় না আচ্ছা এটা করি আছে তাহলে এটা করি এটা জানিস যে এমএস হচ্ছে এমএস টা দেয় না করি দেখ এই করি আচ্ছা আরেকটা অপারেটর আছে যে ধরনের অপারেটর কল এস প্লাস যেটা করিয়েছে হচ্ছে এসএক্স plus ISY, and L plus operator was LX plus ILY, and S shift operator. Shift operator. So shift operator. These two we can. Okay, now here is something interesting. We had to do a lot with angular momentum. We had to find out harmonic polynomials. We had to. We had to do a lot of stuff to figure out that these are the angular. ऐसे ही छोटा ही पे. So we did a lot of stuff, and why did we do that? To figure out how did the wave functions look like, how many wave functions were there, etc., etc. In spin, we don't do that. Why don't we do that? Any guesses why don't we do all those treatment in spin? Really? Special noise. Special noise. Okay, I need to know more about spin, like you said. So the question was, we did a lot with angular momentum. We could have done the same algebra with spin, but we don't do.
Because it will come out from observable power.
Can ADP? Because there are only two. Plus or minus one. We know what is there. We are putting it by hand. Our life is easy. ঠিক আছে? Fine.